2.2, rate of change and slope. As we have seen in 2.1, when we have a table like this, so x is going up by 1 at a time, 0, 1, 2, 3, 4, 5, 6. Y is going up 3 at a time, 13, 16, 19, 22, 25, 28, 31. This is an example of constant rate of change, and the rate of change is 3 for y. What about this one? This is really the same table as the last one, except we removed x equals 1, x equals 3, and x equals 5. Some students might think, hey, the rate of change is now 6 because we're going up by 6. But that's not right, because we can easily fill in the blanks, and we see that the rate of change is still 3. So if we have a table like this, again, the rate of change is not 6 because the rate of change is how quickly y is changing when x is going up by 1. So when x goes up by 1, y goes up by 3. So the rate of change of y with respect to x has to be 3. Okay. So again, rate of change is how much y changes when x changes by 1. So this one then, again, x is changing by 2, so we need to fill in the blanks. When x is changing by 1, how much is y changing? Well, the number in the middle of 15 and 25 is 20. So whenever x changes by 1, y changes by 5. So the rate of change is actually 5. What about this one? Well, this time x is going up by 3. So to fill in the blanks, we would have to do this 1, 2, 4, 5, like that. Well, how much is y going up every time? Well, in total, y is going up by 9. So y goes up by 9 whenever x goes up by 3. That means that y goes up by 3 whenever x goes up by 1. So each step is plus 3 when x goes up by 1. So that means that the rate of change is actually 3. Is there a formula, a general method of doing this? Yeah. So we know that the rate of change is the change in y divided by the change in x. So for this one, the change in y is 9. The change in x is 3, because we're going from 0 to 3. 9 divided by 3 is 3. So if we have a question like this, the rate y is changing from 15 to 27. So the change has to be 27 minus 15. That's the change in y. X is going from 0 to 3. So the change is 3 minus 0. So the rate of change has to be the change in y, which is 27 minus 15, divided by the change in x, 3 minus 0. So that's 12 divided by 3, which is 4. For this one, the rate of change of y is 14. Why? Because it is 34 minus 20, which gives us 14. And the next one will also give us 14 because we have constant rate of change. 48 minus 34, 14. And this one, we're going up by 7 every time. So the rate of change is the change in y minus the change in x, which is equal to 14 over 7, which is 2. One final example. For this one, the change in y is 12 minus 5, which is 7. The change in x is 2 minus 0. When that happens, the rate of change is change in y minus divided by change in x, which is 7 divided by 2. You can just write that as a fraction. 7 over 2 is fine. That's the rate of change. Okay. Well, that's rate of change of a table. But we know from the last lesson that when we have constant rate of change, we plot the points, make a line graph. The line will be straight. So whenever we have constant rate of change, the graph is represented by a straight line. When we have a straight line, we can find the slope. The constant rate of change for this table is 20, because every time x goes up by 1, y goes up by 20. If the constant rate of change of a table is 20, then the slope of the line has to also be 20. How do we calculate the slope? Well, for this one, we want to find the change in y. The way we do that is we can go up 1, 2, 3. So the change in y is 3. Divide by the change in x. In this case, it's 1. So the change in y over the change in x is 3 over 1, or 3 divided by 1, which is 3. So the slope is 3. From the table, we can see that as x goes up by 1, y goes up by 3. Okay. Next one. This time, we are going up 1, 2, 3, 4. So the rate of change in y is 4. The rate of change in x, we count 1, 2. So it's 4 over 2. 4 over 2 is 4 divided by 2, which is 2. If the slope is 2, the table also has to have the rate of change of 2. And that makes sense because going from 1 to 5, that's 4. Going from 0 to 2, that's a change of 2. So the slope has to be 4 over 2, which is 2. Next one. For this one, y is going up. So we have a point here, and we have a point here. So 1, 2. Y goes up by 2. And sure enough, we're going from 3 to 5. We're going up by 2. X, we're going from here, 1, 2, 3, 4, 5. And in our table, x is going from 0 to 5, which is also plus 5. So the change in y is 2. The change of x is 5. So the slope of the line is 2 over 5. You can just write it as a fraction. 2 over 5. The rate of change of the table works the same way. It's also 2 over 5. Last one. Well, this time, we're not going up, we're going down. Well, that works the same way. It's just that if we're going down, whoops, let's try this again. When we're going down, it's not, the change is not plus 2, it's negative 2. but we're still going to the right 3. X is still increasing by 3. So the change in y must be negative 2. The change in x must be 3. So the slope, we would say, is negative 2 over 3. So, okay. Negative 2 over 3. The rate of change in the table is the same as negative 2 over 3. Okay, that's it.